Okay, so Kyle, what is the current situation with COVID right now in our local hospitals?
Um, so, it's sort of interesting when you said we did the first program back in April. It's sort of hard to imagine that COVID is still with us so many months later, but it's also the situation now is very different than it was back in April. We're seeing a lot of COVID in the hospitals, which I'm sure you all know. You watch the news, you follow the numbers. The Cleveland Clinic across all of its hospitals has had a little bit over 700 cases, non-ICU COVID admitted patients for the last couple of weeks. And really, since the beginning of November, we've just been seeing we started seeing a steady increase in the number of patients. Just to sort of give you, a sense on a smaller scale, the hospital I work in, we used to have, I work out at Avon, so it's a relatively small hospital, but it basically until November, we had 0 to 4 COVID patients, and now we consistently have like between 35 to 40. So that's the hard part. The good news is that we're much better equipped now to treat it than I think our colleagues in New York were back in March, April, and May. We understand the disease a lot better. The clinical presentation obviously has not really changed much. People are coming in with the same symptoms. The time course is pretty much exactly what you're hearing. Patients tend to be, they start having symptoms usually about a week after they have their exposure. They tend to get sick and need to be hospitalized about a week after that, which is generally the trend that we've been seeing. The good news is that we've got pretty good at treating it. The vast majority of patients are getting better. We don't have a lot of tricks up our sleeves, which is sort of interesting, but essentially anyone who comes into the hospital and requires oxygen because of COVID gets treated with steroids. They get remdesivir unless they have some problems that exclude them, which is sort of interesting we're still using that. The evidence for remdesivir is sort of the evidence for steroids has actually been great. And we use blood thinners. Those are really the mainstays of treatment now for COVID, non-ICU COVID patients, which is mainly what I treat. And for the most part, patients are getting better, but the numbers are high. And some of the interesting things is that pretty much everyone who gets admitted with COVID seems to know where they got it. Everyone can say, oh yeah, I had dinner with friends. My daughter came home from college. It's been going around my poker game. Anecdotally, at least, there's almost nobody who just says like, I don't know, I don't go out. I don't go out and I don't know where I got it.
Okay, Rachel, I think you're unmuted now. So just turning things over to you. We've been hearing a lot about how the vaccines that have come out, the Pfizer vaccine that has been administered, I think the Moderna vaccine people are going to start getting that very soon. We've heard a lot about how they're mRNA vaccines. What is mRNA?
That is a great question. So before I answer that question.
I think you're muted on your end, Rachel. Right? No. Try that. Oh, okay. Sorry. I had the volume off, I think. Oh, no, wrong, Rachel.
Okay.
Okay, let's try that again. Sorry, I'm sorry. I had the volume off on my end.
Okay. Listen, I'm a teacher. I know all too well the follies of Zoom. So mRNA. So before we talk about mRNA, let's make sure we're all on the same page with the genetic material in general, right? I think most people have heard of DNA, and that's our genetic material that has all the information for all the proteins that our cell needs to make to work. Proteins are the type of molecules that do all the jobs in the cell, and their codes, the instructions for making those proteins, are contained in the DNA. So when we say the genetic material, your genes are passed on to your kids, it's those codes for those proteins that the cells need to do all the jobs of the cell. The issue is that the DNA stays sequestered in the nucleus and doesn't leave. But the protein machines that build the proteins from the code, from the instructions in the DNA, live outside the nucleus. And so how do we get the information that's encoded in the DNA to these protein machines outside the nucleus floating around the rest of the cell? And so that's why we have messenger RNA, or mRNA for short. So RNA is a very similar protein to DNA, but instead of the very, very long DNA where it has many, many genes all in one long string, mRNA is written for one gene at a time. It codes for just one protein at a time. And so it makes a copy of one protein information from the DNA, and it leaves the nucleus, never to return. And it goes and finds a protein machine called a ribosome, and it acts as the template for the ribosome to copy to make the protein that the cell needs. So every time a cell needs to build a protein, the DNA piece that codes for that protein gets copied into a messenger. That messenger RNA then leaves the nucleus to find a protein machine to then act as the template for that protein to be copied. So all the cells in our body are making mRNA right now because our cells are always making new proteins. And so this is a very normal process. In fact, this sequence of DNA getting copied into messenger RNA, which then gets copied into protein, is literally called the central dogma of biology. This is like the basic tenet upon which all of molecular biology is built.
And so how do mRNA vaccines work?
Great. So mRNA vaccines contain the sequence of mRNA to code for the viral spike protein of SARS-CoV-2, which is the virus that causes COVID-19. And so this spike protein, right, if you've seen any of the cartoons of the coronavirus, it's a ball with spiky things on top, right? So the spiky things are these spike proteins that are critical for the virus to get into the cells of the patient, right? And so the hope is that if our immune system will attack that spike protein, it would be able to eliminate the virus and prevent it from getting into the cell. And so what the mRNA vaccine contains is the coding for that viral spike protein. It's enclosed in a little fat bubble because our cells are enclosed in fat bubbles. And if you've ever tried to mix oil and water, making a salad dressing or making your chicken soup, oil and water don't mix. And so in order for something to get into the cell and pass through its fat layer, you need something else that's fat to be able to mix together. And so in order to get the mRNA into the cell, which is what we need to happen for the vaccine to work, it is coated in a little fat bubble. And that little fat bubble will then hopefully merge with the human cell of the patient and let the mRNA of the vaccine into the cell. Once the mRNA gets into a human cell, it is going to act like every other mRNA in that person's cell. It will find a protein machine called a ribosome and act as the template for the virus spike protein to be made by the patient's cells. Once that protein is made, a cell is going to then express it on the surface of the cell, and it's going to act as a flag for the immune system to find. Because what happens when a new protein, right, whether it's attached to a virus or a bacteria or not, whenever a new protein exists in our body, it's like a flag, and the immune system cells come and find it and say, hey, this isn't supposed to be here. This isn't part of me. This isn't mine. And it recognizes it, and it makes antibodies against it, and it makes an army of immune cells that can recognize it to then attack it and block it if it ever sees it again. And so basically this mRNA vaccine is training our cells to make this viral protein, and then our immune system can recognize it. So this way, if we ever encounter the COVID-19 virus of its own, we'll know what to do. Our immune system will know what it looks like and be geared and ready to go. So this is a little different from classical vaccines, where classical vaccines are either attenuated virus, so virus that's been made so that it can't replicate, or killed virus that also can't replicate, or just pieces of viral protein, so not even whole viruses. And so then you have the viral protein floating around in your body, and your immune cells can do the same thing, can recognize it as foreign and can mount a response against it, so that if it ever sees the real virus, it knows what to do. So here, instead of inoculating patients with the protein of the virus itself, we are giving the patients the mRNA so that their own cells can make this viral protein for a short period of time, just enough time for the immune system to recognize it and mount a response.
And is there any reason to think that it sounds like mRNA exists outside of DNA. Is there any reason to think that mRNA could alter our DNA in some way?
Absolutely not. Okay? mRNA cannot re-enter the nucleus. This mRNA is going to stay outside the nucleus. It is going to serve as a template to make viral protein for a short period of time, and then it is going to be broken down, never to be seen in your cells again. mRNA is very, 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 very unstable. DNA is very stable. DNA, so I was a former researcher, and I did research with DNA, with proteins, with mRNA, all various times. DNA can sit out on a tabletop for months. It is completely stable. mRNA, if I don't have it sitting on dry ice, it will be gone in minutes. It just is very, very unstable. It will not last in your cells for very long. And so that combined, right, the instability of it, combined with the fact that it does not go back into the nucleus, it does not get copied into DNA, it cannot get into your genome, it certainly cannot be passed along to the next generation. RNA is not going anywhere near the nucleus.
So thank you for giving us some of that background. Michael, I'm wondering, can you tell us just a little bit also about how vaccine trials work?
Sure. I just want to say that was a really great explanation. I love the description of the ribosome as a protein machine.
Thank you.
Yeah, so the way that vaccine trials work, and these vaccine trials were stood up incredibly quickly because there was so much cooperation from the government, so much funding, so much sort of guarantee that if you made this vaccine, people would buy it. You wouldn't have to advertise it. I mean, all the scientists in the world, all the drug companies, everybody was looking to try to do this as quickly as possible. And one of the advantages of the mRNA vaccines is you don't actually have to have the virus. You don't have to grow the virus. You don't have to try to manufacture the viral proteins. You just have to know the mRNA code, which somebody could just give you the code. It's and then you can make your own mRNA, and then once you've made it, then the cells become the factory that's creating the protein that you need in order to make the immune response. So the way that the vaccine trials work is they have the active vaccine that they've produced, and those were ready. By summer they had vaccines that they were ready to test. And you get a bunch of volunteers, in this case, tens of thousands of volunteers, and half the people get injected with the vaccine and half the people get a placebo. So nobody knows who has it, and then they keep track of everybody. They ask you to record your symptoms that you develop for the next weeks and months. really reporting everything that happens to you in case you have any kind of reaction, in case you have any strange symptoms, develop any diseases. And for the most part, any kind of side effects are going to happen early on, like in the hours to days, and rarely weeks. We don't know of any vaccines that cause long-term side effects, so we don't have things that show up years later. And then you start to collect cases. So in these cases, in these vaccine trials, what they looked at was the number of people who developed symptoms of COVID and then had a diagnosed case of COVID. They didn't go and test everybody every week to see if people were asymptomatic carriers. So we don't know what kind of impact it has on asymptomatic cases. We only know about symptomatic cases. And so they followed the people until they developed enough symptomatic cases that they could assess whether the people in the vaccine arm got fewer cases than the people on the placebo arm. So if you can imagine, if there are 100 cases and 50 of them are in the vaccine arm and 50 of them are in the control arm, then that vaccine has no efficacy. There's no difference between the two arms. However, if you've got 100 cases in the control arm and 0 cases in the efficacy arm, in the intervention arm, then your vaccine has 100% efficacy. It prevented 100% of cases, because you would have expected to see the same number in both arms of the study. So, a typical vaccine, if it's 70, 80% effective, people get pretty excited about it. So the first shingles vaccine that came out, you remember Zostavax, was about 66% effective, and that was a $150, $200 vaccine, and people were excited because you could prevent shingles, or at least 2/3 of the cases of shingles, which was a lot better than nothing. So these vaccines, these mRNA vaccines, have turned out to be much more effective than pretty much anything we've seen before. Both the Pfizer and the Moderna vaccines are turned out to be about 95% effective. So for every 100 cases that you would see in the control arm, you would see 5 cases in the vaccine arm. And not only are they both extremely effective, but the effectiveness begins almost immediately. So you can see that they both require 2 doses. And that's part of the problem of getting something up and running so fast, is we don't really know what happens if you only get 1 dose, because we don't have a study where they just gave people 1 dose and then followed them out for a year. So the recommendation is for 2 doses, but it looks like about 7 days after the first dose, you started to see the curves between the two arms of the study separate. So early on, you've got the same number of cases in both groups, but after 7 days in the vaccine group, it's just straight across, no more new cases. In the control arm, you just see the cases going up and up. And, I guess there's a silver lining to some things, that the fact that we've had this, the second wave of COVID with so many cases has made it much faster to finish up the vaccine trials. So, the first 100 cases took them many, many months to accrue 100 cases. But the next 100 cases took like 2 weeks. So now we've got many, many cases in both studies. And so we're quite confident around the effectiveness of the vaccine. The sort of caveat to that is these vaccines have to be stored at a very cold temperature. As you heard before, that the mRNA is very unstable. So you can't, just kind of stick it in your refrigerator. So these have to be transported on dry ice, and then they need to be kept really cold the Pfizer vaccine needs, I think, negative 90 degrees, and the Moderna vaccine is negative 20 degrees. So right up until just before you're going to inject it. And so only, regular doctors' offices aren't going to have the equipment to be able to do this. So this is going to have to be sort of centrally administered. But hospitals can do this, and some of the drugstore chains are going to be able to do this. So the tricky part now is, how to make sure that we get the vaccine out to the entire country, that we get it prioritized properly, and that we get it to people in, to have it administered in the way that it needs to be administered.
And as much as we've seen reports about how effective the vaccine is, there have also been reports about people having adverse reactions. How much should we be concerned about those reports?
Yeah, so the adverse reactions are, have been allergic reactions in people that had allergies to components of the medium that the vaccine is contained in. We don't think that it's a reaction to the mRNA itself. And so people who've had allergic reactions to vaccines before, and we're talking real allergic reactions, not, my arm got sore or I felt kind of sick for a day. Those people are probably going to have to be cautious about getting the vaccine. They do, it is recommended that they observe you after they give the vaccine. So you're probably going to wait around for a while after you've had the vaccine for 20 or 30 minutes just to make sure that you're okay. But there's no, this does not appear to be a vaccine that is more dangerous than any other vaccine that when you think about, that we're going to give millions of doses of this, we've already given, tens or probably hundreds of thousands of doses already. And I think that, the handful of severe reactions, you've heard about them. You've probably heard about every one of them. So this is not a vaccine that is, has anything about it that's concerning. Obviously, it's been very, very scrutinized by lots of people at every stage because, people were so concerned about a vaccine that was developed quickly. But again, the reason that it was developed quickly is that because there were so many resources put into this and so many people who were willing to volunteer to be vaccinated. I can tell you that, most times you're trying to do a study and you go out and you ask for volunteers, you don't get a lot of volunteers. You usually have to pay people a lot of money to get them to, to come and volunteer to be in a study. In this case, there's no other vaccine. People saw the benefit of and a lot of people volunteered to be in the study. And all of those people who were in the original trials, if they got the placebo, were guaranteed that once it was shown to be effective, that they would get the active vaccine. And so they're sort of they're in that first group of people who are being vaccinated.
So other than people though who, let's say, have a history of adverse reactions to vaccines or allergies to vaccines in the past, is there anyone else who shouldn't get this vaccine?
Not really. I mean, there is I think there are groups of people, I think that the most glaring thing is children in whom it hasn't been tested. They weren't, I don't know why they weren't in the first, round of testing. But there's no reason that I can think of that children would be different, that they have a different immune system or any reason why they shouldn't react in the same way. Now, the two vaccines that have been approved are just the first two companies to come out. There are other vaccines that are not mRNA vaccines. There are spike protein vaccines and more traditionally made vaccines. And, I don't know how close any of those are to approval at this point. The AstraZeneca study showed theirs was much less effective. It was about 70% effective, what we expect from sort of typical vaccines. And then there are other studies that haven't even begun yet. There are some, companies that are just starting their vaccine trials now. But I think there were something like at least 7 or 9 different companies that were working on this, and I don't know what the status of each of them.
So I guess none of us have a crystal ball here, but as we move through the winter and into the spring, do you think people will get to choose the vaccine they get, or will you sort of be assigned a vaccine?
I mean, you could ask me where the stock market will be in April or May. It's really hard to know. If all the vaccines are successful and they're all approved, that would be fantastic, and maybe people will have an opportunity to choose their vaccines. Right now, basically nobody can get a vaccine if you're not a frontline health worker. The next round is going to be sort of emergency first responders and then people over the age of 75. And I'm not sure exactly how they're going to decide who, because there's a lot of people over the age of 75. There are 20 million healthcare workers in the United States. So that's sort of that sucks up all the first round of vaccine. And there are, several million people in nursing homes. So they're the other sort of prioritized group. But once we go on to sort of the next wave, I don't think I haven't heard anything about how they're going to actually prioritize it in a local level. So those are ideas, from the CDC about how it should be done. But each state is getting their own supply of vaccine, and I don't know what the state of Ohio is going to do in terms of deciding when you've got millions and millions of people over the age of 75 who all want to be vaccinated. How are they going to hand it out without having everybody sort of converge on Walgreens on the same day?
So that'll be something we can look forward to seeing and waiting for in the coming months.
I don't think you want to have sort of a line of people spread 6 feet apart when it's 20 degrees outside, standing there for hours waiting to be vaccinated. So they'll have to come up with some kind of an allocation.
Right. Rachel, just to ask sorry, there's some beeping in the background, but just to ask a follow-up question. I know the hazards of being on Zoom. Is there any reason to think that let's say an mRNA vaccine it seems right now at least like the Pfizer and Moderna vaccine is more effective than the AstraZeneca vaccine? Is there any reason to think that a traditional vaccine would be safer or better than a mRNA vaccine? Oh, I have to unmute you. This time you're muted. Okay.
Okay. So kind of as Dr. Rothberg said, no crystal ball here, but most vaccine side effects come up in the first hours to days after the vaccine, and certainly no more than 4, max 6 weeks is what I've been hearing from the experts in the field. And we have, 100 years plus of vaccine data to work with. So the fact that we have safety data from the trials, for all participants, at least 2 months, but for, now we're several months out, even from, several weeks out rather from there. And we have even 3 or 4 months data, safety data from a lot of these participants. We're not seeing any red flags that, would suggest that these vaccines are more dangerous, I think was the word you used, than any, typical vaccine. That's not to say that as we then, vaccinate millions of people, we might not see things like we didn't see the allergic reactions, right, to the vaccine in the trials. That was most likely because people with known allergies to other injectables and other vaccines were excluded from both of these trials, to my knowledge. So that makes sense that we didn't necessarily see an allergic reaction in the trial, but we're seeing it now. Again, as Dr. Rothberg said, 3, 4 of them after we've now vaccinated hundreds of thousands, not so concerning, kind of par for the course with vaccines in general. So while we don't have long-term data, we don't really expect there to be any long-term issues. And so right now, what I'm seeing and what I'm seeing experts say is that we don't really have reason to believe that they would be any less safe. You know, but I think everyone likes to see data instead of speculation. And so, you know, what we have is what we have in front of us. So it's going to be impossible to say with absolute certainty, but there's nothing that suggests that that would be the case.
So I know Sherry posted in the chat a question that I guess in Israel they're thinking about vaccinating children first because they're seen as being either, I don't know if these are young children or you know, adolescents, they're seen as being super spreaders. And I think even here there has been some discussion about this, maybe a Times op-ed that I saw, arguing that instead of vaccinating older people, say people older than 75 in the sort of second wave of vaccines, instead it should be 18 to 30-year-olds or 18 to 40-year-olds because they're more likely to spread it if they contract it because they're more likely to have a mild case or be asymptomatic. Any comments about what the best policy is for vaccinating the population?
I have, you know, a couple of comments about vaccinating children first. I haven't seen that. I would suspect that no government would want to do that if the children were not included in the trial, although we don't have data to suspect that it would be a problem, as Dr. Rothberg said. I haven't seen that. I'm curious to know, you know, to see more about that. The idea of vaccinating the 30-year-olds, that's interesting to me because they are definitely the super spreaders, right? If they're going out to parties and they're going out to bars and they're getting together, that's interesting. But right now, we don't have data on whether this vaccine actually prevents asymptomatic spread. We expect that it will to some degree, but we don't have that data because they didn't test everybody in the trial to see, well, do you have COVID even if you don't have symptoms? They were only looking at symptom presentation. So they don't actually have data yet. They're working on it, but they don't have data yet to talk about how this vaccine prevents spread. So I think my understanding is then that we should protect the most vulnerable. But that's just my opinion.
Yeah, I mean, nobody's asking us. So
why not?
You know, this is the kind of thing that is done, you know, you need models to try to figure out which is the most effective way to prevent deaths, you know, and to prevent the spread. Obviously, you know, the vaccinating people over 75 is not going to prevent much spread, but it might prevent more deaths. You know, nursing homes make a lot of sense because the people in nursing homes are both likely to have it spread in the nursing home, and they're very high mortality. So that one's an easy one. The rest of it is a little bit harder. I mean, I think it's a little bit similar to the mask thing, you know, that we understand that masks are primarily for protecting other people, but if you see who's most likely to wear a mask, it's the people over the age of 75. They're not spreading it to anybody. They're wearing the mask to protect themselves. That's a sort of a natural human response. But, you know, so that's sort of where we are with the vaccines. But I don't think we're going to have an option on that. I think a more compelling question is whether we should be vaccinating people who have already had COVID. You know, we're now inoculating 250,000 people a day with the real thing. So, you know, whether it makes sense to vaccinate those people when we've got, you know, a limited supply of vaccine is a good question. I think right now they're sort of saying, you know, if you've had it in the last 3 months, you don't need to get vaccinated. Nobody knows how long the natural immunity lasts. No one knows how long the vaccine immunity is going to last. But you know, I would expect that people who have the natural immunity are going to probably be protected for you know, a good long time. So we hope to study that and have an answer for you in a few weeks.
Okay, so we'll look forward to that. Another question that was in the chat: what happens to the vaccine if it's not the right temperature? It breaks down in some way, I assume.
Yeah, I mean, it's basically just not going to be effective.
And Any thoughts on vaccinating the vaccine for people who are on immunosuppressing medication?
I mean, it's probably not going to be as effective if your immune system isn't able to create, to have an immune response, but you'll probably get some response, and it's probably better than nothing. It's not going to hurt you, because again, there is no virus in this vaccine. There is just the instruction for your body to make the spike protein, which by itself can't hurt you.
So that some people also sent me questions in ahead of time, and if you have more questions, keep putting them in the chat. But just a couple of questions that were emailed to me. Generally speaking, what are the medically or scientifically supported reasons for not getting the vaccine?
I can't really think of
any.
any.
Jinx, can't think of any.
Okay. Are hospitals in any way incentivized through reimbursements to inflate the number of either COVID patients or COVID deaths? I think this has been sort of, I've been amazed by how many people have mentioned this question to me, actually.
Yeah. Well, maybe people were thinking that when there were 10,000 deaths, when there were 100,000 deaths, 200,000 deaths. I don't know, at what point a person can really wrap their head around what's been going on in the country. But I mean, so many people have died, and I don't know how many healthcare workers need to tell you that the hospitals are overflowing, that all these people have COVID, that they're taking care of COVID patients. They're not taking care of people who came in with heart attack and they happen to have COVID, or they had a stroke and they happen to have COVID. These are COVID patients. That is just insane. And so, I mean, I understand at the beginning these were sort of like interesting questions, but these have been settled so long ago that to keep bringing it up, I'm just I'm a little passionate about it.
Another point that I think is worth mentioning is that when the hospitals get overrun, they cancel elective surgeries. The hospitals lose a ton of money by canceling these elective surgeries. So that doesn't benefit anybody. So they wouldn't be doing that if they didn't actually need to.
Yeah, they don't actually make money taking care of COVID patients. We lose a ton of money taking care of COVID patients. It's we're much better off make all the money from elective surgeries. COVID patients, it doesn't even cover the cost of taking care of them. When someone's in the ICU for weeks and weeks, that's a money loser for the hospital.
No, I was going to just echo that. These patients really have COVID. You can't make up COVID.
So another question that was emailed in, if for whatever reason a person doesn't get vaccinated, what is the model for keeping others, say members of a synagogue, the person was asking specifically, who have had the vaccine healthy and COVID-free? So if you have a community where some people are getting the vaccine, some people aren't, how do you ensure everyone's health and safety?
So, I mean, people who have not gotten the vaccine, people who have the vaccine and people who have not gotten the vaccine, as long as there's still COVID, being transmitted in the community, are going to have to take the same safeguards. The vaccine's not 100% effective. Even the new amazing vaccines are not 100% effective. So you can't say that when you go into shul that you're not going to spread it to anybody. So we're still going to have to wear masks. We're going to have to stay far apart. We're going to have to do all the things that we're doing now. But our hope is that when we get to somewhere around 70% of the population, who has either been vaccinated or infected, that the cases will, there won't be enough people left to infect for the virus to continue to spread. And so at that point, it'll sort of disappear. And then we'll be able to go about our lives. Don't know when that's going to be. The faster they come out with the vaccine, the more people we can get vaccinated, the faster we'll get there. But in the interim, we're going to be doing what we're doing now. It's going to be a while.
So going back to a question that was put in the chat that Androy asked, why do you need a second dose? And how long does the vaccine last? And when would you need to get the vaccine again? If the single dose might be effective as well.
Yeah, we don't know. I mean, they didn't study it with people getting a single dose, so we don't know. You know, there's certainly no harm in getting the second dose. That's what everybody got. And I'm sure that they'll roll it out that way. How long the vaccine's going to last, again, you know, we don't know. Most vaccines last for, you know, a number of years at least. So there's no reason to think that this one's going to be different. I'm sure many of you've heard that there's a new strain now that's been detected in the UK. Don't know what how the vaccine will work on the new strain. It will probably work on the new strain, but we don't know. There may be other new strains. Again, when you've got 250,000 people being infected every day, just in this country, there are opportunities for new strains to develop. The more the virus replicates itself, the more it has a chance to mutate. So there may be new strains that come along that are not susceptible to the vaccine. And then we might need to come out with a vaccine against those. But I'm getting ahead of myself because we don't have evidence for any of that yet.
What is jumping to another topic, what is the potential for mRNA vaccines for other diseases or other viruses, especially like HIV?
There's a big potential. There are already RNA vaccine type treatments in being tested for certain cancers. I believe they are trying to develop one for HIV as well as for Zika. This is, I read cursorily. I have not spent a lot of time reading into that, but there are definitely RNA vaccines on the pipeline that are being tested now and in development.
I just also want to read a comment that I think Dr. Worthington sent in the chat, just that a significant benefit of a traditional vaccine compared to the RNA vaccines that are currently available is that the RNA vaccines, as we talked about, have to be kept at a low temperature, and presumably a more traditional vaccine would not have to be kept at such a low temperature, and that might be an advantage when they become available. Another question that was sent in, and I know has come up in some places, is the potential impact of an RNA vaccine on fertility, and that there's been some discussion that the proteins from an RNA vaccine would attack the placenta in some way. Is there any reason to be concerned about that?
I can't see how. I mean, the protein is just the spike protein, which by itself isn't going to do anything. It's got to be attached to a virus. That's the beauty of this technology. I mean, we started out, hundreds of years ago by taking viruses and then just trying to weaken the virus or give you some other, either a weakened virus or a killed virus. And the killed viruses didn't usually work as well as the weakened virus. More recently, we've gotten to vaccines, like the new Shingrix vaccine doesn't even include the virus. It's just a couple of pieces of the virus with an adjuvant that's, revs up your immune system to create a response to the protein. So I think, we've gotten away from the possibility of the virus infecting you or causing any harm and focused on these other kinds of technologies that, create safer vaccines. That's the good thing about technology is we get better and, things work better than they used to work.
Yeah, so just to add to that, I think that specific piece of misinformation was circulated a couple of weeks ago, and it was suggesting that there is a protein that's important for embryo implantation into the placenta that they were saying was similar to the spike protein. It is not. There were experts that looked into it. They had like tiny not at all significant similarities. And so the fear was that if we develop an immune response to the spike protein because of this vaccine, well, then our bodies would attack a placenta also. There's a lot of evidence against that, mostly that anyone with COVID would also have antibodies against the spike protein, right? Anyone who actually had the real viral infection would also have made antibodies against the spike protein. And so there's no evidence that anybody who has had COVID has now suffered from, subsequent infertility. So that's number one. And number two, again, these experts looked at the protein sequences and structures and said, no, this is a complete hoax. So there's no basis to that claim.
I think this will be the last question. And again, I think to ask the three of you to look into a crystal ball a little bit. But how likely we are to just expect that we're going to get a COVID shot at some point in some point in the future in the way we get a flu shot? Or is the flu vaccine different in some way?
Well, I mean, the flu vaccine is different in that flu mutates every year. So your flu vaccine from last year is not going to cover the strains of flu that we have for this year, though they are working on universal flu vaccine that, maybe you only need to get it once. But we don't know, these viruses, the coronaviruses, the ones that cause, SARS viruses have not been around for very long. So we don't know enough about them. This is only the second one. We had the SARS virus, in 2003 or 2004 or whatever, and now we've got, this is SARS-CoV-2. This is the second SARS virus. So we really don't know enough about what to expect for these viruses going forward to know if we're going to need to vaccinate people against them every year, what the vaccine is going to look like in terms of, this vaccine effort that we have going on now it's a kind of a national effort. It's been rolled out with the Army delivering the vaccines to specific places in huge numbers so that we can, do a national mobilization. We don't do that with flu vaccine. We do that in doctors' offices and drugstores and whatever, and we don't need any special equipment in order to be able to do that. So, ideally we'll be able to figure out how to do this better over time. I'm sure that the technology will improve, but right now we're just sort of focused on getting through this because it's been a little bit disruptive to our lives, and then we'll see, where we go from here with the newer technologies that come along.
So I'm actually going to give one more question that just came in that Muriel asked. Has Haya been vaccinated?
Not yet. I'm waiting. I should be getting it within the next week or two, most likely.
So I think your supervisor told you would be on that.
Yes, I treat COVID patients, so I'm definitely on, the next round in the first wave over the next couple of weeks. So I will be getting it. I will be taking it. I'm very excited to get it. It's been a long time coming, and I'm very hopeful that the end is near. So I'm very excited.
So thank you everyone for joining us tonight. And thank you to Rachel and Michael and Haya for sharing their expertise with us. I learned a lot, very informative. And I know that all three of them, I think, are happy to field more questions. I'm volunteering you. I'm glad that that they're all nodding. So if you need their emails, or you can find them on, at least Rachel and Haya, you can find on Facebook. I think Michael, you can find on Twitter. But I'm sure they'd be happy to continue the discussion and answer any additional questions you have. So I'll go ahead and stop the recording and also unmute if people want to say hello for a minute. There are a lot of us on though, so I imagine there'll be some background noise.